Okay, so this is the first problem of today's contest, and in this we are given that we have a permutation A of size n, and we can do the following operations. That is, we can select an index I from 2 to n minus 1 such that A of I minus 1 is less than AI. Like AI is bigger than both of its neighbors. So then if this is true, we can swap AI and AI plus 1. So we have to determine whether it's possible to sort the permutation after a finite number of operations or not. So first of all, everybody here knows what a permutation is, right? Is anyone having any doubt what a permutation is? Just write a quick yes, no. Like there is a definition also given, I think. Basically, a permutation is that every integer from 1 to n appears exactly once in this permutation and the order is any random. So see, what we can do, we can select index I if this is more than both of these. And we can shift this, like we can swap these two. So after some operations, what we want, 1, 2, 3, all the way up till n. And since this is a permutation, this n will be occurring exactly once in this permutation. So let's say n is here. So one thing is for sure that this n, wherever it is existing, like occurring, I can always shift that from anywhere from 2 to n minus 1 to last place. Why? Because it will always be the maximum element. Like it is not about whether this n is more than its left neighbor or right neighbor. It is bigger than every other element. So we can always make this n come to this place. So now if my array is this much, let's forget that this n was even part of my permutation. Let's say my permutation was itself of size n minus 1. So the problem still is the same. I can always bring all of these integers here, but there is only one problem. That is, I cannot make my 1 come here if it is not here. Why? Now let me explain why. If 1 is not here, I cannot swap this element, the first element. If it is anything 2, 3, 4, I can never select this I. I will never be able to swap this element with any other element. So this element finally will remain unchanged. I can swap all of these elements somehow. Like if I select this as my I, I can swap these two. But this won't get swapped with any other element. So initially, if this is 1, I'm good to go. I can sort the complete permutation. And if it is not, then I won't be able to. So are there any doubts? Okay, I think the doubts are already answered, right? Is it okay, the explanation, or is anyone still having any doubt? Okay, it's okay. So in this problem, we just have to check whether the first element is 1 or not. If it is 1, answer is yes. Otherwise, the answer is no. Why? Because like I said, we'll first try to bring our n to the last place. Then we'll try to bring n minus 1 to the second last place. And while we are doing this, it is always feasible because if n is anywhere in between, it is always more than its left neighbor and right neighbor. Once n comes here, this n minus 1, wherever it is, it will always be more than its left neighbor and right neighbor, unless it comes to this place. So let me show you the implementation. So this is the implementation. In this, I have first taken array A as input. Like, don't get confused with this. This is me taking the complete array as input. Then this is, if the first element is 1, then the answer is yes. Otherwise, the answer is no. So going to the next problem. In this, we are given that we have a string S of length n consisting of characters A and B. Now you are allowed to do the following operation. Choose an index I between 1 and n minus 1 such that Si is A and Si plus 1 is B. Then we can swap Si and Si plus 1. Now, we are only allowed to do this operation at most once for each index I between 1 and n minus 1. Now, these operations can be done in any order. So we have to find the maximum number of operations that we can carry out. So let me explain the problem statement quickly. See, we are given, we have a string that has characters only A and B. And now we can swap to I and I plus 1 indices if and only if, first of all, I is not selected, I was not swapped earlier, and I contains A and this contains B. Now, we have to find what are the maximum number of operations that we can perform. So this is a very simple problem. See, if let's say there is a B here and there is a A here. So if there is a B here, like this was the first A, and this is the last B. Like after this, there is an A. So first of all, if this is the last B, can any, like after this only A occurs. So is there any possible way that I can have any swaps after this position? No, right? Because see, after a swap, a B will go in forward direction and a A will come in backward direction. But I want this kind of orientation for a swap. So in this part, a swap is never possible because how can a B come at this place? Because B only moves in forward direction and A only goes in backward direction. So after this a B can never end up. So in this part, there can't be any swap. Same holds for this part. There can't be any swap in this part. Now, as far as these two places are concerned, what about these two? So first of all, my claim is I can have swap for each and every position here, like from here to here. First of all, like try to understand what I'm claiming. I'm saying that it's possible for me to have between these two places, like can have all of these eyes as my choices, irrespective of what is here and what is here. Like it can be AB, it can be AB here, whatever in between these two. Now let me explain how. See, if there is a here and somewhere here it's a B, so I can always swap these two, right? So B will, like, it's always possible for me to bring this B to this place, irrespective of what here is, A, B. If there is a B, it doesn't matter. Like this A will come here, this B will come here. Like at the end, all the B's that were in between these two, they will end up here, and all the A's will end up here, right? So in a way, here will come an A, here will come a B. So we would have done all the operations choosing all of these I's. Is it making sense? Yes, no? Between the first A and the last B.
Yes.
Okay. Now, like how can I write the number of operations? It is nothing but the index of last B index minus first A. And that is our answer. The only thing that you'll have to make sure that you're not printing something which is negative. See, it's quite possible that we get this as our input. So in this case, the last B is this, the first A is this. So this doesn't mean that the answer is -1. Your answer will be 0. So our answer is maximum of 0, comma. Is it clear? Okay, so let me show the implementation. So this is the implementation. In this, I have first taken n as input, then I have taken string s as input. So this is the first position of A. This is the last position of B. Like don't worry about the 0 LL. Then for each index from 0 to n, I'm like just finding what is the minimum position of A that I can get. And otherwise, if this is B, so by default, whatever max was up till now, I can update it to I. Like I can write the same thing here, but it won't make any sense. So mx will have the maximum position or maximum index at which B is, and mn will have the minimum index at which A is. Finally, my answer is maximum of 0 or mx minus mn. Is that clear? Okay. Okay, let's take an example. Like I have a doubt, like I have a problem in a doubt in chat. So let's take an example. So this is the doubt, like how will we have operations on this? So like by the theory that I have explained you, I said we'll find, first let's try to find the answer for this. So first position of A, last position of B. And by this, I'm saying like we'll have 4 operations. Now let's see how those 4 operations are. See, I can select this as my I and I'll get BA here. I can select these as my I. So this is one operation. This is second operation. I'll get A, B, and these are the 2 places which I cannot select now. A, B, A, B, A. Now, after this, I'll select this. Like I can select both of these. So first I'll select this. So I'll get B, A, B, A. And then I'll select this. So I'll get B, A, B, A. Right? Did I do something wrong? First of all, okay, sorry. I'll explain it again. Like I forgot to reshare my screen. See, so this is the string that we have, right? So by the code or by the theory that I have explained you, the answer should be minimum A, like the position of minimum A, and we'll find the last B, that is this minus this. So that is 4, right? Now let's see how this 4 operations will come. So first, I can do operations between these two. So this is my I. So it will become A, B, B, A. Then I'll do here one operation. So these two. So it will become A, B, A, B, A, right? And then I can choose any of these two. So let's say I chose this. So it will become B, A, B, A. And then finally I can choose this. So it will become B, A, B, A, A. Now I cannot select this again. Why? Because this has been already selected once, this I. I cannot select this one because this has been already selected. So let me mark these. So all the vertices that I cannot select. So I cannot select this one. Why? Because it has already been done here. I cannot select this because this has already been done here. I cannot select this because this has already been done here. And I cannot select this. So like you might be thinking like, let's do one more swap here, but this has already been selected once. So I cannot do this again. So here we have 4. Now this is the answer, right? So eventually what happened, there is a B at this place and there is a A at this place. So all the indices that appear in this part have been chosen at least once or exactly once. So that's why the answer is last position of B minus the first position of A. Is it clear now?
Yes.
Okay. So let's go to the next problem. So in this, we are given that we have 2 arrays A and B of size n. And the beauty of array A and B is the number of indices I such that AI is more than BI. Now we are given an integer X and we need to determine that whether or not it's possible to rearrange the elements of B such that the beauty of arrays becomes X. And if it is possible, we need to output this valid rearrangement of B. So let me first explain. See, we have this array A. Okay, let me explain. Let me share the screen. So we have this array A and we have this array B. And the beauty, the beauty is defined as the number of indices I such that number of indices I such that number of high indices that AI is more than BI. So if this is X, this is fixed, right? So we want exactly X places to have such that AI is more than BI. And all the remaining places should have AI less than equals to BI. So this is X and this is N minus X. So let's assume for first that our array A is sorted. Okay. Like let's assume that the array A that we have, this array is sorted. And let's say this array is given to us like it is. So we have like these n values and this array A is sorted in non-decreasing order. So the array values are, let me, like if I show it like graph, they are increasing. So first value is this much, second value is this much. So the values are increasing or they are same, but they are not decreasing. Now, if I have to first choose like X value such that AI is more than BI, what do you think, which X values are most like, and the remaining, like these are X positions should have this thing and N minus X positions should have AI less than equals to BI. So first of all, if this is my array B, like array B is right now in random order. So first of all, tell me if you have to, like by intuition, what do you think, which X places should be chosen for array A? Like forget about array B, such that AI is more than BI. So by intuition, we get that those should be the maximum values of array A. Why? If I have to pick some values which should be more than BI, by default, I'll pick the maximum. I can prove this also, but first try to get it by intuition. If let's say X is 2, I'll always pick these two for these X positions. You can say, why not? Like, why not choose these two? Because if you like, instead of taking A1 and A2, like if my indexing starts from 0, instead of taking these two, now this is like I'm trying to prove this. Why? Because if you take these two and answer is valid, like answer is possible, then if you even chose these two instead of these, the answer will still be valid. Like you cannot go wrong, right? Because instead of taking these values, you took bigger values for these places, and by default for the remaining places, the places that are left, you're choosing smaller values. You are left with smaller values, so your answer will still be valid. So from intuition and by proof also, we get that the last, if I have to take X, the X places that will be like this, the X position, those places should have these X values in array A. So, but first of all, I cannot change array A. I can change only array B. So, but assuming, let's say the values were sorted, these will be the X places, or X places will have these numbers for which AI will be more than BI. Now tell me by intuition, if let's say array B was also sorted in same order, let's say this is array B. This is array B. Then which values will you choose? These values are also increasing. Let me show you in more. These values. These will be, again, by intuition, again, first X values. If I chose 3 first. Why? Because if your answer is, if instead of taking this, you are taking this and the answer is still valid, then it won't make your answer invalid if you chose the smaller X values. Because for this part, bigger X values, bigger BI values will be left. So we'll do the exact same thing first. First of all, the only thing, like this part is clear. The only thing that was required in this problem is implementation. How will you implement this? So one of the ways to implement this is, first, you cannot change your array A, right? And you can change your array B, but you need to print your answer relative to array A. So first, let's say what we can do. Up till now, everything is clear, right? First X values, last X values, what I have done. Okay. And by the way, if this, after doing this, if the answer is not possible, then answer won't be possible anyways. Then it's just after after this kind of observation, what you can do, you can make a new array or a vector in which you will have the first value as the array AI, and the second will be AI. So let's make a pair, right? And we can sort these values. So after sorting, you will get exactly array A like this, but you'll have the position, like this is I1, like this is this value appeared at second place, this value appeared. occurred at first place. This value occurred at fourth place. Forget about the remaining values right now. Forget about these values. I'll explain this in a moment. We are just looking at these X values. Like we're trying to fix these values with these. Like this is AI and this is BI. This is AI and this is BI. And we are trying to make such that AI is more than BI. If this is not true, anyway, like you cannot take this and this because BI has increased. You cannot take this and this because AI has decreased. So this is your best option to get at least X such that, like exactly X such that AI is more than BI, right? So we are right now worried about only this part. Now, how to get this part? First, sort your array A, and then according to at this place, like once you sort this, at the last X places, you'll have the indices, and at those places, try to fix these values. Like in your original, like in your from your original array B, try to take the smallest B value, X values, and try to give these positions for your answer, like your answer B. You'll have to print this, right? So for these places, try to fix these. This part is clear, right? Yes, no. Like I'll explain it again if it is not clear to anyone. Okay. So now one thing we have done, that is, see, if this was not, we were not able to do this for X values, the answer is no, straightforward. But let's say we were able to do this. Now for the remaining things, our target is to do AI is less than equals to BI, right? So again, by intuition, or like you can again prove this thing, that we'll try to have these values. So let me see. First of all, let's say this is your array A. It's sorted in increasing order. So these are the values. They are increasing, and this is your array B. Again, sorted in increasing order. So let's say X was 2. So what we will do, first of all, we'll try to have these two values and these two. So we'll try to have at this index, we'll have this value of B at this index, which is the fifth position, we'll have this value of B. And for the remaining, what we can do, for the remaining, that is these three, and these three will follow the same thing. That is, this value will come at this index, this value will come at this index, and this value will come at this index. If the answer is not possible this way, the answer is no. Otherwise, we can print our array B. So we just have to rearrange our array B in this order. Is anyone having any doubt? Now you might think, like, why not take, instead of taking this value, why not take this value in here? Like maybe it is also valid. But even if it's valid, there is no harm doing this also, right? This is, if that is valid, this will also be valid. But it's not vice versa true. Is it clear? We are trying to take the smallest X values for these places of array B because we want X places to have AI more than BI. And for the remaining N minus X places, we want AI less than equals to BI. So we are taking the maximum B values and minimum A values. Just like we are doing just this thing. Is it clear?
Yes.
Okay, so let me go through this. So this is the implementation. In this, first I have taken array A and array B as input. Then I have inserted array B values into a multiset. You don't like, okay, this is not required. I don't know why I did this. And then I've inserted array A values in a pair of vector. And like I said, this is array A value at ith index, and this is the ith index. Now I have sorted both of these in non-decreasing order. Then this is my answer vector that I'll print. Now this is just a flag for checking whether the answer is possible or not, whether it's possible for me to rearrange array B such that the required condition is met. So for the X places, I want, see, these are the biggest X places. In my VP was nothing but array A after sorting, right? So for the biggest X places, this is array B's smallest, like smallest X values. Why? X minus I. So X minus I is X, so we'll start from 0 and we'll go to X minus 1 because I will end up at 1. And similarly here, like And after assigning these values, I'm just making sure like you don't have to do it actually here. We can do this afterwards because finally our answer will be this answer, right? This is our answer. So what we can do, we can have a for loop here and we can check whether for every index, like how many indices there are such that answer of I is less than or answer of I is less than A of I. So answer is nothing but rearranged array B. So you can check it here also. So if it is exactly equals to X, then your answer is yes and print the answer vector. Otherwise your answer is no. So, but I have done it here only. So while assigning these X values, I'm checking for this at this index. If this is more than this, like these are same indices. This is index and this is index. The first value FF was the first value of the pair. It was this value and SS is second value, which is the index. And for the remaining n minus x values, don't get confused with these. Like this is just to figure out at which index I'll end up at. So I'm just doing the remaining, like I'm assigning the remaining values and I'm checking the same thing. So is it clear?
Yes.
Okay. So let's go to the next problem. So in this problem, we're given that we have a one indexed array A of length n and where each element is either 1 or 2. Now we have to process Q queries of the following two types. The first one is 1s, that is to check if there exists a subarray of A whose sum is S. And the second query is 2iv. In this, we need to check if AI is changed, like we don't have to check anything, we just have to change AI to V. No, this is just the like the definition of subarray. I hope like everybody knows this. And we have to answer Q queries. Okay. Now this problem just require observation and it is like after that it's really easy to solve. Let's say this is our array A and it has ones, like it only has ones and twos. Okay. Now we have to answer, like we have to perform two, like we don't actually have to perform, but we have to compute two types of queries. In first query, we have to check whether or not there exists a subarray which has a sum of S. And in second query, we have to update AI with V, right? So first of all, tell me, forget about these types of queries. First of all, if I give you, let's say, what is the sum of this, by the way, this array 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 is the sum, right? For like, let's say there is anything which is like, this is the sum. If I give you any value as my query, let's say X, first of all, if X is more than sum, what do you think, what will be the answer? If this is the case, is there any subarray? No, right? So yes, the answer will be no. Straightforward, the answer is no. You don't have to do anything. Now let's say the only object, like pay attention. If let's say there is the differences between these two. After this point, sum is, because I have discarded these cases when X was more than sum. So sum minus X. So this is my difference. Now let's say if this difference turns out to be divisible by 2. What do you think? Is our answer possible? Now look at this array. See, my claim is answer is always possible in this case. Always possible. Why? And I'll go even for like I'll go even like ahead and I'll say like what you can do. How is the answer possible? Let's say you fix your L here, you fix your R here. If let's say and you let's say maintain a variable S, I'm proving that the answer is always possible. Your target is this thing, and right now your sum is this thing. Now either you'll have a 1 here, like what are the four possibilities? You're having a 1 here, 1 here. Let me write the possibilities here. So LR. So either you're having 1 at both places, you're having 2 at both places, you're having 1 here, 2 here, 2 here, 1 here. So now for this case, the difference between these two is divisible by 2. Now, while this difference is more than 0, what we can do, while the sum is more than x, we want to make this sum as x. So we want to adjust our L and R in such a way that the sum becomes equals to x. And I'm saying this is always possible. Why? Because see, if these are the 4 cases and the difference between sum and x is divisible by 2, what we can do, if let's say, if this is the case, what I can do, I can subtract my R, like I can shift my R one place to the left. Why? Because if sum was more than x and this was true, either sum will be equals to x or this will still be true. I haven't changed the parity of difference. And just try to understand this point. My difference was earlier, it was 4, now it will become 2. Because at this place, there was a 2. I haven't changed the parity. Are you trying to understanding my point? If I shift my R one place to the left, I am not changing the parity of my sum. I'm just decreasing it by 2. So either my sum will be equals to x, or the difference will still be a multiple of 2. Is it clear? If at the rth index, initially your L is at the first place, R is at the last index, there are these 4 possibilities. If rth index is having a 2, if you shift your R one place to the left, your difference from the sum is now from L to R, and your difference between sum and x will still be a multiple of 2. You haven't changed the parity of sum. It is still a multiple of 2, so that's why you haven't changed the parity of difference. Is it clear now? Okay. So similarly for this, we can shift our L to one place to the left, right? That is here. If this place was having a 2. Why? Again, I'm not changing the parity. If this is, you can change any L and R, any of these two. You can choose any and you can shift accordingly. And if this is the case, you'll have to shift both. Like if your difference is more than 0 and it's divisible by 2, if this is also true, then because if this is true, this is also true, difference is more than 0, difference is nothing but the difference between these two. And if difference is divisible by 2, you can shift both of these L and R, L to one place to the right and R to one place to the left, and the difference will again change by a factor of 2, that is by exactly 2. So the difference will still be a multiple of 2. So this, if you keep doing these kinds of steps, eventually you'll end up at some L and R for which your sum will exactly be equals to x. Is it making sense? Yes, no. Is it if it's not, just write a no in the chat. Otherwise, if it's clear, let me know. Write a yes in the chat. If you don't write anything, how will I know? What about others? Okay. So I think only there are, okay, what you can do, let's try to have a conversation here. You can unmute yourself. Anyone who is not understanding, who will unmute? Probably whoever is a little confused, you can unmute yourself. We'll try to have a conversation and it will be much better for you.
Am I audible?
Yes, you're audible. See.
So I just didn't get that part. You said that if I move left to the right.
Yes. See, each and
then
every
why-
element. Okay. Oh, yeah. Yes. Continue.
Okay, so you're saying why can't the difference change by 1 instead of only a factor of 2?
Okay, because we are shifting. See, these are the four. See, these are the 4 possible values, right? L is having 1, R is having 1, both are having 2. One is having 1 and other one is having 2. Now I'll shift only that place which is having a 2. That's why my difference will not change by 1. I'll always change my L or R. I'll always shift my L only when the value at here was 2. I'll only shift my R when the value here was 2. And in case both were having 1, I'll shift both of these. That's why my
So
difference.
the whole array is only 1?
What?
What if the whole array is only filled with 1?
It doesn't matter. See, if every a complete array is filled by 1, what is the sum of this? 1, 2, 3, 4, 5, 6, 7, 8. Let's say this is the sum and you want to make 5. Your L is here, your R is here, right? This is your difference. This is your problem, right? This is your doubt. So what is the difference? Difference is 4. 4 is divisible by 2. Yes. So I'm saying this is always possible. So why? See, both of these places are having 1, 1. I'll shift my L here, my R here. So by what did my difference change by? 2. So now the difference is 2. Again, I'll shift my L here, R here. So this is my final array whose sum is equals to X. That is 5.
But if we were trying to create something like 6,
What?
if we were trying to create a sum
Okay,
of
okay.
6,
Yes. So that condition I haven't discussed right now. I have discussed only if difference is divisible by 2. I'll come to that in a moment. Is it clear? Okay. So now the only condition that is left is difference is not divisible by 2. Like this is not 0. And like sum is still more than X. Because if sum was not more than X, if sum is less than X, then your answer doesn't exist. So these two conditions are true now. So tell me one thing. For the first time, let's say 1 occurs here, and for the last time, 1 occurs here. So can you not treat this as two arrays? First array is this, and for this thing, your sum is sum minus X will again act as sum minus X will act as what? This will be even. Difference will be even. By this I mean difference will be even, right? Like I can break my array. Why? Because I'm not including this last one, because this was changing my parity of sum. I'm making my sum parity as parity of X such that so that the difference becomes even. So let me explain this again. See, previous cases, first of all, previous case is clear to everyone, right? If sum is even, the answer is always possible, right? So let's say these are my places. So I'm saying let's try to break this array into some sub arrays such that the sum of those, right now I know like the parity of my sum is not equals to the parity of my sum is not equals to the parity of X. X is what is given to me in input, right? Now, what is the biggest subarray? See, eventually I just want, because in the previous case, the answer was always possible if sum minus difference, if sum minus X is even, the answer is always possible, right? We have already discussed this. Just the only requirement is the sum should be more than equals to X. So in this also, we'll try to do the same thing. We'll try to divide this sub array into some sub arrays. The only thing is, let's try to divide those sub arrays into as big as possible so that we get the maximum sum dash. Let's say sum dash is the sum of those sub arrays. If this sum dash is more than X and the parity of this sum dash is equals to the parity of X, then the answer is possible, right? So this is the only thing that we have to check. So I'm saying one array is this that we can check. Why? Because if we take this one also, then again the parity of these two won't be same. We can take this. What is the remaining thing that we can take? Anyone? Like we can take from, okay, actually I think these two should be enough. No, first of all, if you're thinking of this thing, well, this doesn't make sense. The parity will still be not same, and this is already a sub part of this. Like during solving the problem, I think I have taken these two also, but I don't think they are required. Yep, like these are sub parts of this only. Like this is bigger. We always want the bigger one. And if you are having doubt why not taking this part, first of all, the parity will remain same. And if you're thinking why not take this part, again, this is this complete part is in this subarray. Like I have to eventually the biggest subarray only matters, like the maximum. From these two also I'll take the maximum only. So let's say these are the two subarrays. The parity of these two subarrays will be same as parity of like let's say this is sum 1 dash and this is sum 2 dash. So parity of these two will be sum 1 dash parity will be equals to sum 2 dash, and which will be equals to x. So if any of these sums is more than, like the bigger of these sums is more than x, the answer is always possible, bigger than or equals to, because like I explained in the previous, I cannot take, like there is no subarray. If I take one more element here, the parity will change. That's why. So I hope this is clear, right? So let me show you the implementation. So first I've taken n and q as input. Then for finding C, till now, finding the first and last, how will you find these? So I have inserted these in my set, like in implement one set, or like just have a set in which all the places which are having one, all the indices which are having one will be stored. So we can easily find what is the first place of any index which is having one, and what is the last place which is having an index one. So that's why I've used this set. Now I'm taking array A as input, and I am, if the ith place is having one, I'm inserting that index to my set. Now this is my segment tree. I'm initializing it using A. Why? Because finding range sum here, I'm finding range sum, right? What is the range sum of this and what is the range sum of this? So I have used a segment tree. Like I omitted these details, but because these are implementation details. While like explaining the logic, I didn't include these because later you might like try to solve this problem and you will come up with a completely different approach. So you don't actually have to implement this problem using the same thing, but the idea will remain same. So for each query, first take the type as input. If the type is 2, it means we have to update. So take index I and v as input. If like index I was having 1, erase that from your set. Like our set was having this, right? Because our set is having all the places which are having ones. Then update your index I. Now, if it is 1, insert back it into your set. Then update your segment tree accordingly. Otherwise, if the query is of type 1, take v as input. Now this v is nothing but x. You want your final sum to be more than this v. Finally, this is your total sum. Like right now, your array sum is this much. So first of all, if this is your v, if this v is more than your sum, your answer is not possible. Simply print no and continue. Otherwise, this is your difference. If difference is divisible by 2, simply print yes. Otherwise, find the maximum between, you don't have to find between 1 and f. It will get included between, like it is 1 and L only. And similarly, you don't have to find between L and N. So this is your first position, first index of your S, first position of your F, and this is your last position of your index 1. So find the maximum of these two. If V, that is the sum that you want, is less than or equals to mx, print yes, otherwise print no. Is it clear?
Yeah, it's clear.
Okay, so that's it. And thanks for joining. Bye-bye.